All right, so I've planned a simple agenda for us. To give you a bit of the insight into the exciting world and concepts of systems engineering. I'll start with my background, talk about the importance of understanding the customer problem, explain what system testing is, cover the importance of looking at your products or solution from a customer perspective and user scenario. Then I'm going to expand that into levels of testing, how that fits across the overall wing-to-wing process, and then close with the concepts of what I call PICMO and how it can drive quality solutions. So a little bit about me. I spent the last 30 years working for a small number of companies. The first 7 was for TRW as a manufacturing engineer, and then as a quality engineer. After that, I went to Northern Nevada, to the Bentley, Nevada business, which was acquired by GE in 2002. We're now a part of the Baker Hughes, a GE company. I've held a variety of roles, both in and outside of quality, that included sourcing, finance, quality leadership, master black belt, product line management, global audit, and my current role as the engineering leader for our systems engineering and system test and validation team. Additionally, I'm an innovation coach, which at GE is called a FastWorks coach, where we mentor and coach the product development teams to successful outcomes. I'm an active member of ASQ's Northern Nevada section, and I hold several different ASQ certifications. So let's take a quick scan of the definitions on this slide, and I'll pause while you go ahead and read those definitions. Okay, so system testing is the validation of the system, the subsystems, and the associated environment to replicate how the product solutions are used as a comprehensive offering. In order to understand system testing, one must first understand what a system is. When you think of a system, think about all the components of that system. So I had traveled to one of our sites that develops one of our software products a few years ago, and I asked the group if they do system testing. I received a confident response of, well, yeah, we do. And from their perspective, they were right. From my perspective, they were simply testing a product. It was a software team, and the software team considered the overall software solution as a system, because it was made up of multiple features developed separately together by different Scrum teams. But it's a single product that is part of an overall solution that includes hardware, the software product, and the associated infrastructure. You can't test the system unless you test the interfaces and interoperability of that solution together. For example, think of an automobile. There are a significant number of components and subsystems that make up the automobile. You start with a lot of raw material and components. From there, you would create the engine, the body, the interior, the tires, the safety systems, the sound system, that's just to name a few. And there's suppliers for many of those parts. However, they are all part of a very intricate design that takes into account certain factors like efficiency, comfort, safety, aesthetics, right? Additionally, it's not only the vehicle that's part of the system, there's everything that happens at the manufacturing facilities, the shipping, the logistics to move it to the dealers, the dealership, the selling process, the financing, registration and insurance process. Then there's the maintenance and service practices, not to mention all the manuals that go along with that, as well as the electronic equipment to service it. The gas stations, charging station, if it's an electronic car, then ultimately the disposition of the retired vehicle. Even with all of that, I'm sure I forgot at least one or two additional subsystems that go along with the overall system from the perspective of an automobile. So the point is, a system needs to look at everything in the value chain, and even those things that aren't in the value chain but make up part of the solution. With that being said, how in the world would you test all of that? Well, you start with scenarios, and the scenario would represent how the customer would use it. But not just one customer, you have to think about the different customers, as not all customers are alike. As an example, right, consumers in their 20s and 30s have significantly different needs than consumers that are in their 50s and 60s. So the operational scenarios for those users would be different. So operational scenarios, right? These are basic scenarios that reflect how a customer may use, interface with, or interact with a product. For example, think about the automobile that I mentioned earlier, right? An operational scenario could be as follows. You are a driver who has just passed your driver license test and are still in the probationary phase of driving. You have access to your parents' car and prepare to drive it to the store. Your route includes an area you are unfamiliar with, so you program the location into the navigation system. You get in the car, set the seat to your comfort level, and save it as driver number 3, right? You start the car, put it in reverse, and back out of the driveway. You follow the map and voice on the navigation system and arrive at the store. You park in the parking lot, lock the car, and do your shopping. You return to the car, unlock it, store your purchases in the trunk, then drive home. So in this simple scenario, there are multiple testable elements. The navigation system access. Could you program that while you were not in park? Was it accurate? Was the voice pleasant? How about the car itself? Did you get a seatbelt warning? Did it brake acceptably? Did the blinkers work? How was the acceleration? Did all the gauges work? Were they accurate? Were you able to store your seat, mirrors, steering wheel to a comfort level? How about the backup camera? Did that work? Was it accurate? And then after returning to the car, was the seat still set to your comfort level? So these are just a few of the things that you could test, whether it's simulated or actual, to support the operational scenario. The simple fact is that typical consumer doesn't buy parts of a car, they buy a complete car and expect that everything will work and that the dependencies of the components will work. For example, the navigation system only working or being able to be programmed while the car is in park. So as noted on the previous slide, right, how different would the scenario be if we were talking about a driver in their 70s or 80s? So we'll talk more about that in the next couple slides. System requirements. So this is the entire solution, right? So if we use our new driver operational scenario, you would consider not only the car, but can also look at the other parts of the experience, the terrain, the weather, the routes. Really, the sky's the limit for where this could go. Then think about that driver in their 70s or 80s. They may not even care about a navigation system due to the complexity of programming it, or about the backup camera. They may, however, care about the seatbelt warning, the comfort level, etc. So the point here is that the system requirements need to address measurable attributes and functionality that a consumer would be looking for in a solution. From there, the next facet of definition is your functional requirements. So functional requirements really are going to look at what does your vehicle or your car need to do. So here's some examples, right? It shall have a restraint system for passengers, and it shall transport up to 4 passengers. It shall contain a storage area of 2 cubic yards. You could actually add a tolerance there if you wanted to. And it shall go from 0 to 60 miles per hour in 7 seconds plus or minus a second. Right? So those are some functional requirements that are very customer facing. So if an innovator gets those wrong, it's really hard to be successful with your product. And if you think of, many vehicles you may have purchased in your lifetime, how many times have you hopped in and said, wow, what were they thinking when they did this design? What were they after when they put, this cup holder here, or when they put some sort of dial on the dashboard where it's hidden behind the steering wheel, depending on how you have the steering wheel set. Those are the kind of things I think about from a testing perspective is how did those get past the testing process? Performance requirements are what we call the ILITs: reliability, usability, serviceability, manufacturability, responsiveness, things like that, right? And you can get your performance requirements by asking some very simple how questions. How long should the car last, right? How fast should it accelerate? Or how fast does it accelerate? And this would be where your acceleration requirement from the previous slide would come into play. How smoothly should it roll? How often do you change the tires? One of them, and I think this is an interesting one, is how large or how small do the tires need to be? With today's electronics in vehicles, if you've got a electronic speedometer, it's based upon and calibrated to the diameter of your tires. So if you change your tires to smaller or larger, it's going to affect the accuracy of your speedometer as well as the accuracy of your odometer. That's something that, to me, it's a system requirement, and there should be something in the vehicle that is actually changed at the time you put those tires on to recalibrate those critical parts of your car. Speedometer for sure, odometer as well. So we've talked about operational scenarios, system requirements, functional requirements, and the ILITs. But when do you test what? When do you perform verification and validation? So verification is similar to the inspection activities that are performed during the manufacturing processes of a product. From a development perspective, it's performed on the various steps of the development and requirements creation portion. One of the ways to look at the cycle is through the use of the V model. So the V model is a simple way to look at what testing you do at what levels of the process and development. The question is, who does the testing at what level? Is it a build the quality in or identify the gaps through testing? If so, you want to start at the lowest point in the process. System testing is the most comprehensive testing that we can do, and it's the testing that should identify customer use issues, not basic functionality defects. One of the critical points on this too is when we talk about build quality in versus identifying the gaps through testing. Obviously, we always want to build that quality in, because you can't really test quality in, you can test defects out. And so as you set up your scheme for testing, obviously you want to make sure that you're testing as much as you can at the lowest levels, because it costs more every time you find it at a further level in the process where you've added more cost from parts, resource, labor, as well as time as you go through your processes. So again, your system testing, typically that's one of the last things you're doing, and if you're finding your defects there, it's a little late, but it's certainly better to find them there than when they get out to the customer. So think about what wing-to-wing might mean to you. Right? We talked about requirements, verification, and validation, and about the V model. Let's take a step deeper into the overall system thinking methodologies and talk about the wing-to-wing approach, sometimes referred to as end-to-end. It's a basic term used in manufacturing and in development. For the purposes of inspection, testing, and systems, I think about it as the starting and stopping point in the life cycle of a product, starting with a customer problem and ending in a product's retirement. So each one of the critical functions within an organization matters. And as you look at this slide, there is a tremendous number of icons here. So the idea is you start with a customer problem and you've got some sort of an idea, right, of how you can satisfy that customer need. When you do that, then of course you're going to get the customer input. That customer input should then drive your operational scenarios, your functional requirements, so that you know what it is that you need to develop. And each one of those functional requirements needs to be mapped out and well thought out. So from there, you've got your customer input. That's probably when you're going to start getting a little bit more money to move along with that project, right? You do your research and innovation, you do development, you do some testing, you think about your technical regs and standards, and then of course you get more money. The key there is as you're doing development and as you're doing test and as you're doing those regulatory reviews, you're also gathering more requirements. And you're looking at what your manufacturing team's going to need, what your sourcing team is going to need, right? And so as you go through all of these different icons, each one of them has needs that should drive requirements that help you to get your product solution correct, not only for what's going out for the customer, but what you need in order to do your product development both effectively from a cost perspective, but also getting your releases out on time at the right quality that you want. So as you look through, manufacturing has requirements, right? Most of you have probably heard of the thought of test-driven development, right? So when you are looking at your QA and your QC as well as your testing, you think about if we have those requirements correctly and everything is laid in, and we think about how can we test it as we're writing those requirements, it can help you drive to have a more simplistic test approach that is going to replicate how your customers are going to see that. So again, lots of icons here. So now let's think about why does wing-to-wing matter, right? So if you think about all the icons on the previous slide, right, there's a bunch of bullets on this one, but think about, is there a customer need, right? How many times have you seen a product where you wonder, what were they thinking when they developed that? What were they going after? What was that customer need? And if there's not a customer need, then again, the likelihood of having a successful product is pretty slim. And then the thought is, can we develop a solution to meet that need? So not only is that the technology side, but also the resource side. What are the resources you need, from investment money, personnel, infrastructure, all the support to create a solution. And then can we sell it? So do you have a set of training requirements? Do you have everything you need for your sales team to be able to sell that? And then can we manufacture it? When we manufacture it, do we have what we need to be able to test and inspect and validate that it's acceptable? Have we gone through and set up all of those parameters, both for what we expect the suppliers to do and for what we're going to do in our own facility? So now we've created it, we've got the selling ability, it goes out to a manufacturer, a customer, whether it is being sold at a service center, a store, online, whatever the case may be. Do we have the ability to install it? Do we need to install it, or does the customer install it? And do we have proper instructions for them to do so? I think about if you ever get anything from IKEA or Office Depot or any of those stores where you have to construct it yourself, how often do you do that construction and you find that it's missing a screw or it's not labeled properly? Those are all things that we should have good either inspection or testing or work materials to make sure that when it gets to the customer, they can put it together, they can install it. And then if it's something that we have to service, do we have everything set up and in play to do that servicing? Do we have the right instructions, the right equipment, the right computer programs, the right mechanical items? Is everything that we need to service it put within our calibration system, right? And then at the same time, if it's something that a customer has to return to a facility, is there a mechanism for them to return it? Do we have that all set up in our return system where if a customer is doing a drop down for that product, that they can see that and do that return? And really the reason I bring a lot of these up is when we talk about inspection and testing, we should be testing out every one of those systems to make sure that they're there, but also testing it out from a user perspective. So you're looking at the user experience associated with it. When we get to the ability to repair it, right, that's a critical thing, because is it something that we throw away or is it something that we repair? That has to be decided ahead of time, because if it's something that we're going to throw away, we may, if we're not going to do failure analysis on it, we may not even want the customer to ship it back, depending upon the cost for disposal. So those are things that you'd want to make sure that you're looking at and questioning and challenging as you go through the process. If we have a sustaining model where we take customer input and modify the product, we have to look at that. And then if we do modifications, what's our testing to make sure that we're still meeting all the needs? And then if you think about, right, is there a solution that it's replacing? Is there interoperability between the old system and the new one? Does it replace something else? What does it interface with? How will the solution interact with customer infrastructure? Those two bullets, the second and the third, are very critical to perform system testing on. Because again, how is your customer going to use it? What are they going to feel? What are they going to experience? So when you write a scenario, you want to cover those elements to make sure that you're looking at it from a customer perspective. The technical regulations and standards and other regulatory needs is very critical. We live in an environment today where those are changing regularly, and we need to have the checks and balances in our systems to make sure that we're hitting those and that we are validating what we need to make sure that we're good. From a cybersecurity side, one of the biggest areas that we're seeing in today's technologies is customers coming back and looking at from the cyber side, from firewalls. So again, you not only need to design for that, you need to test for it and make sure that it works. Again, lots of things on this slide, but the whole point of that is how do we inspect and test the products throughout the life cycle to ensure that we're building it right and that we're building what is right. And that's where that verification and validation comes into play. So the next thing I want to cover is the PICMO, and I want to go over, this is going to be a complicated slide. Typically I have it build. So if you think about what's on the slide here, what I'm going to do is start over here, and I'm going to use my annotation to help make this a little bit clearer for you. So if we start with what the inputs are, right? So what are the inputs that are required for the process? And my process here is system testing. So we've got the inputs of product, hardware, software, firmware, right? The requirements document and the implementation of a design review. So all of these items here are part of your inputs. From there, you work your way over to the controllers. And on the controllers, what you're going to do is you're going to start with, what do you need, right? So here's all the items that you need. You need your, you need to understand how the process is defined, what are the targets, what's the acceptable criteria or acceptance criteria, you know, how the product's specification is defined, right? So all of these elements are going to define your process, and they are what controls your process. So if you think about that, if you're doing an audit or a check on this and you're looking at what's there, you're going to look at QMS documents, you're going to look at the test strategy, the requirements documents. You know, all these items that are noted here are critical for us to, whether it's an inspection and test, really it's an audit, to make sure that in order to do your system testing, you want to look at all of these items to make sure that they are truly in existence. The next thing you're going to look at is your mechanisms, right? And the mechanisms are going to cover, really it's how, what are the mechanisms you use to control your quality? So it's the equipment, the resources, what's required to properly perform the work. Is it suitable, maintained, the competencies? So this is not just looking at the tools themselves, you're also looking at the personnel and what's required for the personnel to be able to do that task. So when you look at that, right, for us, TFS is a repository that supports our Agile methodology. It's one of the Microsoft tools. We use that to store everything we need in order to know what processes are coming up next. That helps drive our testing and our validations. So when you look at your mechanisms, right, you've got a very critical group of things that you're going to use to make sure that, again, you're getting the system testing done correctly. And then on the final part here, we have the output. And the output is where you're going to get a lot of the inspection piece coming in. And if you look at that, right, you're looking at, are the measures in place, right, to assure that you've got your product? Are the processes measured? Did we achieve all the requirements, right? And then if you, down the road, want to look at what kind of customer feedback you're getting, that's another part of it. The key point on this one is this is where you're looking at your outputs. And keep in mind that the outputs are frequently and almost always the input to the next process. So if you are validating or verifying, right, you want to make sure that you've got everything clean and complete. So if, for example, you are looking at test records are one of your outputs, right? And then those need to go in whatever your repository is. So again, this is what I call a PICMO for process, input, controllers, mechanisms, and outputs. And if you created a PICMO for all of your critical processes, critical steps, wing-to-wing for your system, just imagine what you could uncover in the weaknesses or the vulnerabilities where the overall quality of your solutions could be improved. So in summary, we talked about what system testing is, and to realize the value of system testing, you need to fully understand what your system is. Your system is best defined through operational scenarios that cover how a customer would use the solution, and creating system requirements, functional requirements, and the abilities so that you can focus on those areas for validation and for verification. The intent is, again, not only do we build the right thing, but we also build it right. So if you think back on our automobile example, right? One of the examples of a interoperability or a system test that you could look at is, in today's vehicles, when you are in a crash, right, and you have the bumper hit at a certain mile per hour or higher, right, the airbag deploys, right? In some vehicles, the doors unlock so that if you have your doors locked, right, obviously any sort of emergency personnel can't get in. So imagine how you would test that, right? You're going to have to use crash test dummies, of course, but you're going to have to use the computer printouts and the readouts and everything from kind of the vehicle black box, so to speak, to make sure that everything worked within the right amount of timing, because there would be a timing element to that, to make sure that airbag deployed, that the doors unlocked, and that you could access the passenger in that vehicle. So that's just an example of interoperability that we would need to figure out how to set up our testing to accommodate that. Because yes, we're going to test the ability for the airbag to deploy. We're going to test the ability for the vehicle to unlock. We're going to test the ability for the bumper to withstand a 35-mile-per-hour crash. But then you have to test them all together as a system to make sure that it works. And that's really where that system testing comes into play, because you're looking at the interoperability and the interfaces as opposed to just that single piece. So if we go back to my example of when I was at the site that was testing software and they said, yes, we tested as a system, my question then to follow up there was, okay, but what software does that, what does that solution do? What's the hardware that's associated with that software? What does it operate on? What's the operating system? How often does that get updates? How does it respond to updates? How does it take all the measurements in? So from a software side, if you go out and you look on the internet and you see system testing, system inspection, what you're going to find is oftentimes it talks mostly about software. And my purpose of really wanting to share this information with you is because it's not just the software, it's all the hardware and everything that it's interfaced with. So we also talked about the V model, which is a simple look at the different levels of testing and can be adapted to show a similar view if you replace the development steps with manufacturing steps and the level of testing with levels of inspection. It's a similar concept. The earlier you are in the manufacturing process, the less it costs when you find a defect. It's the parallel to development. From a wing-to-wing process, we need to look at how we are evaluating our processes and planning our processes out from the very beginning to ensure that we aren't letting critical processes or steps go without adequate controls and planning. Finally, the PICMO is a simple way to lay out your process and consider all of the controls and mechanisms that are necessary to create a quality output. Defining what the output should be is all about requirements, the requirements definition, and the flow down. It ties it all together in what I consider a nice little package. So that was what I wanted to share with you today. We've got plenty of time for questions, and I don't see any in the little Q&A section.
Thanks a lot, Lorri, for your presentation. If any of the attendees wish to ask a question, go ahead and type it into the QA chat. I believe Lorri also has visibility of it, so please go ahead. We'll give some time for those questions to come in. Lorri, if anybody wants to contact you or they have any questions, maybe not now, later on, is there an email address they could reach you at or some contact information?
There is, and that was my error. I thought I had it on the slide. In just a second, I'll post that for you.
Okay, we do have something coming in. So